How to optimize TensorFlow Serving for real-time inference. In this video, we will explore practical strategies to maximize TensorFlow Serving efficiency, enhance performance, and reduce latency in deploying machine learning models. Did you know that in today's fast-paced digital world, having a lag in real-time data processing can mean the difference between success and failure for businesses? Welcome to our series on optimizing TensorFlow Serving for real-time inference. In this video, we'll explore why real-time inference is crucial and dive into the practical strategies you need to enhance your TensorFlow Serving performance. Let's get started. Real-time inference is a cornerstone of modern AI applications, from autonomous vehicles to personalized recommendations. However, achieving low latency predictions in real-time poses significant challenges. Latency issues can arise due to network delays, insufficient computational resources, or inefficient model architectures. Additionally, as data throughput demands increase, systems must scale efficiently without compromising on model accuracy. In this segment, we'll discuss these challenges and their implications on performance, setting the stage for understanding how TensorFlow Serving can be optimized to meet these demands.
To achieve optimal performance with TensorFlow Serving, precise configuration is key. The initial setup involves defining server resources such as CPU and memory allocation, which are crucial for handling requests efficiently. Configuration options allow you to fine-tune aspects like model loading times and request handling, directly impacting performance. In this section, we'll guide you through the essential configuration steps, ensuring your TensorFlow Serving setup is primed for efficient real-time inference. Whether you're a beginner or an experienced developer, these tips will help you maximize your model's performance.
Batching is a powerful technique to reduce latency and increase throughput in real-time inference. By grouping multiple requests together, TensorFlow Serving can process them simultaneously, maximizing resource utilization. However, determining the optimal batch size requires careful consideration of the trade-offs between latency and throughput. In this segment, we'll explore how to implement batching in TensorFlow Serving, sharing real-world examples that demonstrate the efficiency gains achievable through this method. By the end, you'll understand how to leverage batching to significantly enhance your inference performance. Parallelism and concurrency are vital for enhancing throughput in real-time inference. While parallelism involves executing multiple processes simultaneously, concurrency allows for overlapping operations. In TensorFlow Serving, configuring parallel requests and concurrency settings can significantly boost throughput. This section delves into the technicalities of setting up parallel and concurrent processes, ensuring balanced resource allocation. We'll also present a case study highlighting substantial throughput improvements, offering you a comprehensive understanding of how to apply these concepts effectively. Managing different versions of machine learning models is crucial for continuous improvement and experimentation. TensorFlow Serving offers robust version control capabilities, allowing you to seamlessly deploy multiple model versions. Coupled with A/B testing, you can validate performance improvements before full-scale deployment. This block covers the importance of maintaining version control, strategies for effective A/B testing, and insights gained from testing outcomes. By mastering these techniques, you'll ensure your deployments are not only optimized for performance but also aligned with business objectives.
Continuous monitoring and logging are integral to maintaining optimal performance in TensorFlow Serving. By tracking key metrics such as latency, throughput, and error rates, you can proactively address issues before they impact your applications. Logging provides a detailed record of system behavior, essential for diagnosing problems. This block highlights best practices for monitoring and logging, including tools and techniques for setting up alerts and analyzing data. We'll also share a case study illustrating how effective monitoring can lead to substantial performance gains.
As your application grows, the ability to scale TensorFlow Serving efficiently becomes paramount. Kubernetes offers a powerful platform for managing and scaling deployments, ensuring your system can handle increased demand seamlessly. In this block, we'll explore the benefits of using Kubernetes for scaling TensorFlow Serving, guiding you through setup, deployment management, and automation of scaling operations. We'll also share real-world achievements in scaling, demonstrating how Kubernetes can transform your real-time inference capabilities.
In this section, we'll examine case studies of organizations that successfully optimize TensorFlow Serving for real-time inference. These examples showcase the strategies implemented, lessons learned, and the remarkable performance improvements achieved. We'll discuss the tangible impact optimization had on business outcomes and explore future trends in TensorFlow Serving optimization. These real-world insights offer invaluable guidance and inspiration as you embark on your own optimization journey. Congratulations on completing this deep dive into optimizing TensorFlow Serving for real-time inference. We've covered a range of strategies, from configuration and batching to scaling with Kubernetes. Remember, the key to mastering these techniques is continuous learning and experimentation. We invite you to apply what you've learned and join our community discussion. Share your experiences, ask questions, and suggest future topics. Your feedback is invaluable as we strive to create content that empowers you to excel in your machine learning endeavors.